All right, what's going on, guys? It's Mr. Jones coming once again. Today we're already going to get ready to go into the math, and we're going to do task 3.5, throwing an interception. It's a develop understanding task, which means we're going to learn something brand new. I like that it's called throwing an interception because right now is football season, and we are in playoffs. We just watched the college football championship, Roll Tide. And so it's kind of an appropriate title to the task. So before we get started, I'm going to go ahead and read it to you, and then we'll go ahead and get rolling. All right. The x-intercepts of the graph of a function f of x are often very important because they are the solution to the equation f of x equals 0. Okay, so right off the bat, what I want you to remember is that f of x and y are the same thing. It's the same thing. So it's just saying whenever you plug in 0, okay, whenever your y value is 0, that's whenever you get your x-intercepts. Okay, in past tasks, we've learned how to find x-intercepts by factoring, which works great for some functions but not for others. In this task, we're going to work on the process to find the x-intercepts of any quadratic function that has them. We'll start by thinking about what we already know, and then we'll generalize to all quadratics that have x-intercepts. Okay, so let's do a little bit of review stuff first. The very first thing I want you guys to do is open up Desmos, go to desmos.com, and then click on the graphing calculator. And then we're going to go ahead and type in the equation. So the equation was x squared minus 2x minus 3. X squared minus 2x minus 3. Okay, you should notice on the bottom there's a little keyboard down here, and you can get the squares and all that if you don't know how to do it on your keyboard. But anywho, there is the graph. So first thing was graph the function. You don't really have to do anything for that. Okay, you're graphing it on Desmos. Okay, then there's two more questions. What's the equation of the axis of symmetry or the line of symmetry? Line is the same as axis. And also, what is the vertex? Okay, so right off the bat, we're going to go ahead and locate the vertex. Boom, there it is. 1, negative 4. So 1, negative 4. I'm going to go ahead and put the equation up here. Okay. So now that we know the vertex of the function, we should be able to come up with the equation of the axis of symmetry. What I'd like you to do is pause the video and look in your notes and see if you remember how to find that equation. All right, hopefully you remember there was something that if you knew the vertex, you automatically knew the axis of symmetry because it's the x value of the vertex. So x equals 1. I'm going to go ahead and type that. And if you hold down right here on this blue circle or whatever color yours is, it'll give you the option to do dashed lines if you want. So now there's the axis of symmetry, x equals 1, and we have located the vertex. Okay, so now let's think specifically about the x-intercepts. Okay, you can see there we still have the same equation, but it's asking what are the x-intercepts. Okay, so we could actually look up the x-intercepts on here, but typically what do we have to do to find the x-intercepts? You have to find out what adds to get negative 2 and what multiplies to get negative 3. Let's see if we can make this a hair bigger here. No. All right, I don't know. Okay, what adds to get negative 2 and multiplies to get negative 3? So if you were to figure that out, you would realize that, let's see, you're going to have a plus 1 and a minus 3. Okay, so this would be factored form, and then the opposites of these, so negative 1 and positive 3. Okay, and then there's zeros, right? So negative 1 and positive 3, and sure enough, if you come to the graph, positive 3 and negative 1 are the x-intercepts. Now, the question is, if you were just to count how far from the x-intercept, how far are the x-intercepts from the axis of symmetry? So just count and see if you can figure that out. So hopefully you looked and you said, okay, here's my axis of symmetry, 1, 2 in the right, 1, 2 to the left. So they are 2 units from the line of symmetry. Okay? And so we're going to refer to that distance as D in a minute, but you'll see. So now we're going to actually do that right now. Let me actually give you a picture here. 1 second. All right, so there's the picture I want to give you guys, and I'll just pull up the task because you're going to have these too. So it says, if you knew the line of symmetry was x equals h. Okay, so we're just going to say that this random parabola was x equals h. We don't know what the number is, but we're just going to call it h. In the one from Desmos, we know that it was 1. Okay, but in this case, it's h. If you knew that the line of symmetry was x equals h, and you knew how far the x-intercepts were from the line of symmetry, so d, right? You knew that distance. How could you calculate the actual x-intercept? So if you knew those two pieces of information, how would you find out where the x-intercepts are? So what I want you to do is, since we know what the equation of the axis of the symmetry is for this graph, right? It's x equals 1. I'll just write that here in blue, even though it doesn't really go here. But we know these two pieces of information, and you can see on the graph on Desmos. How could you figure out what the x-intercepts are? Go ahead and pause and see if you can't figure that out. All right. Well, since we know where we started on the x-axis, and the problem over there below, we started at 1. Right? And once we started at 1 where my mouse is, we just moved 2 to the right. So we added 2 to it. So in that case, to find the x-intercepts, we said 1 plus 2. And that's how we got 3. Or we started at 1 and we subtracted 2 to go in the other direction. So, or we said 1 minus 2 equals -1. So basically, we took our axis of symmetry and we added or subtracted our distance. On your paper, you're going to actually see that to find one of the values, you take your h, which is your axis of symmetry, and you add it to d, okay? And that's going to give you one of the answers. That's your x value, comma 0. Or you're going to take your h value, which is your axis of symmetry, and subtract the distance, comma 0. And so in this case, h was 1 and d was 2. And so we literally did that, and that's how we can figure it out, right? If we knew that distance. It's the same in both directions. All right. D is, but we already knew the x-intercepts anyways in this problem. All right, D says, how far above the vertex are the x-intercepts? Go ahead and pause and figure that out. Okay, so it looks to me if I start at the vertex, I go up 4. Is that right? Did we go up 4? We sure do. 4 units. 4 units. Okay? And remember, the vertex was 1, -4. So how far above? It's just 4 units away, which was the same number as the y value of my vertex. All right, moving on. Lastly, what's the value of f of x at the x-intercepts? Well, what's the value of y at the x-intercepts? The answers are right here. Okay, the answer is always 0. You always set the equation equal to 0 whenever you're solving this. All right, so problem number 3 is the last one we're really going to do and talk about. I want you guys to do this one on your own. So here's the equation, f of x equals x squared minus 6x plus 4. Go ahead and go to Desmos and type that in. And then answer the questions. What's the vertex? What's the equation of the line of symmetry? All of these information you can get either from the graph or from previous in this video. You can go back and remember how we found it the first time. Okay, D, what do you estimate D to be? That means what's the decimal answer? Your answer is going to be a decimal. Okay, you can't find the x-intercepts on this one because this is not factorable. We'll talk about that in a minute. So go ahead and answer these 5 or 6 questions, get the graph on Desmos, and then unpause the video and I'll give you the answers. All right, so very simply the question is, what is the vertex of the function? And you should have found out, oops, I put -4 on accident. This should have been +4. Didn't seem right. You should have found out the vertex was 3, -5. Hopefully you got this right. 3, -5. And the equation of the line of symmetry is x equals 3, right? So you might have typed that in, x equals 3. I like mine dotted or dashed. Go ahead and make it dashed. All right, what are the x-intercepts? You can't factor this one, and that means that the answers are not beautiful. They're decimals. So I'm going to go ahead and write these decimals down. And remember these decimals, or at least have them written down, because we're going to talk about them in the very next video. Okay, so these are approximately what they are, and I should have put comma 0. I'm going to go ahead and do that. Comma 0 and comma 0. Okay, so now it's saying, what do you estimate that distance to be, right? So how can we figure out that distance? Go back and remind yourself, if you didn't get it, how we did it, right? How do we find the distance? Earlier we said that it was h minus d and h plus d, right? So h was 3. So it's going to be 3 plus d equals 5.24, and 3 minus d equals 0.76. Okay, so now all you have to do really is solve one of these, so the distance should be the same. The distance from the axis of symmetry right here to each side should be the same. So on this one right here, boop, all you have to do, I'm going to do it right here. All you have to do is subtract 3 from both sides. And if you do, you get d equals approximately 2.24. The one above it, you have to do the same thing, but you have to, so we're going to subtract 3 from both sides. But we get negative d equals negative 2.24, which means you can multiply both sides by -1, and now you get positive 2.24. So that is the answer for E, positive 2.24. And the value of f of x at the x-intercepts is always 0. So hopefully you guys put that. Now, here's the problem, guys. We don't like decimal answers. The answer of 5.24 and 0.76 are not perfect, and we can't really use those, and we don't like those. So the next video, we're going to talk about how do I find the exact values for x-intercepts, because I'm not going to look for that distance and all that, even though it is important. I'm not going to always have Desmos. So what if I want to find the x-intercepts and it isn't factorable? What can I do? Okay, so that's where this is all going to come into effect. So basically it gets into saying that it's going to have you do a bunch of stuff that you guys don't have to worry about. Okay, so we're going to skip all this. I don't even know if I'm going to give you any of this. I might actually just cut your task off right here and you don't even see them that I'm talking about. So with that being said, make sure you guys have all these notes written down, and then you're going to go check out the video called Quadratic Formula, because that is the method we're going to use to solve for x-intercepts if it's not factorable. So have a great day, guys. Bye.